Hello friends, I welcome you all to this session. Today in our sessions we'll be starting with our trademark course, that is TS and AP, MSET and also KSET. Got it friends? So we'll be starting with the chapter of limits and derivatives. Fine. Actually we will be covering even continuity in this chapter itself, because all these all are what connecting topics. So we'll be starting with limits and derivatives. Before I start with the session, I want to give you certain instructions with respect to these sessions. So every day we'll be having sessions for MSET and KSET, okay, that is in single session, and also we'll be having sessions for JEE, that is JEE, right? But it will be different topics. What we will cover in MSET will be different, and what we'll cover for JEE, that will be different. I request all of you to watch both the sessions, because that will develop or it will broaden your horizon of knowledge. Fine. So every day we'll be having two sessions, and coming to these sessions, since it is for competitive, that is for MSET, KSET and JEE, will be a little fast. Fast in the sense we'll explain the concepts in a proper way, but when it comes to solving questions, we'll be teaching you the tricks. Okay, some questions will solve even the logical way or the normal way so that you understand, but most importantly we'll be focusing on the tricks, because you know that this is competitive exam and we have to solve accurately and also in a very shortest possible time, right? So based on these instructions, I'd like to start this session now. Having said this, now first let us have a look at limits and continuity and derivatives. So don't worry about this. When we talk about limits, there are various topics. Now when I talk about number of questions, okay, these are number of questions when it comes to pertaining to JEE mains, okay, but when we talk about MSET and KSET, every year we are getting an average 2 questions. So 2 questions we are getting an average. 2 questions and an average we are getting from limits and derivatives. And continuity and differentiability, that is a different thing. But when we talk about limits and derivatives, we are getting an average. How many questions? We are getting 2 questions. Okay. When we talk about limits, continuity and derivatives, what is the syllabus? What is the syllabus? That is, we are having limit at a point. Okay, we are having limit at a point, and concept of limit, that is left-handed limit and right-handed limit, and properties of limits, that is algebraic properties, trigonometric properties, all these things. Indeterminate form, what are the different types of indeterminate form, and methods of solving the limits. Okay, suppose if you are getting indeterminate form, what are the different methods to solve the limits? Okay, what are those methods? We have direct substitution method, we have factorization method, we have rationalization method, trigonometric limits. Okay, under trigonometric limits only you will get sandwich theorem. Fine, we are going to study even standard limits, certain standard limits, logarithmic and exponential limits. Now then is 1 to the power of form, 1 to the power of infinity form, infinity by infinity form. When the question arrives at this form, okay, how to solve those questions. Next, when we talk about L'Hopital rule, that is LH rule, then continuity, differentiability and differentiation. This is we are going to cover in after this chapter. First we will cover when pertaining to limits and derivatives. Okay, so in this chapter we will try to cover maximum, that is up to what, various methods of solving the limits, up to logarithmic and exponential we will try to cover. Okay, and first we will tell the concept. Based on the concepts we will see what are the JEE main questions, because solving the JEE main questions will be helpful even in what, solving MSET questions, because they are almost of the JEE main level. If you see the difficulty level, it is almost of the JEE main level. Okay, so solving these questions will be helpful very much while solving in MSET questions and also in KSET questions, right? And after we are done with telling the concept and example questions of JEE and all these things, we will be solving MSET and KSET PYQs, MSET and KSET PYQs pertaining to that topic. Okay, suppose you are completing up till what, various methods of solving the limits, then we will solve PYQs based on those topics. Then next session, if you go for LH rule and all these things pertaining to those topics, we are going to solve the PYQs. So that way it will be very systematic, and for you also understanding will become better. And one more thing I want to tell you is, suppose we are solving in the class, suppose we are solving 10 questions in the class, we request you to solve at least 20 questions or 25 questions on your own. Okay, because that will help you to build the concept by yourself. That will help you to practice the questions. That will make you thorough with that concept. Got it, friends? Now, moving forward, let us talk about the chapter highlights. What are the things that are there in the chapter? So, if I told you average number of questions, JEE Main or MSET, AP set or K set, we are having at least on an average 2 questions. So when you talk about input output ratio means how much of hours you are putting for that topic, what are the output that you are getting. So this requires high output, high input actually. High input if you put, you will get high output. Okay, why high input is required? Because these limits will be useful not just for that particular chapter, but also for differentiability and also in various other topics. Okay, because it is linked to various other topics. Having a foundational concept about limits will help you solve many other questions. Okay, high input, especially limits will be easy. Limits would be easy. Next, what are the prerequisites knowledge that is required for solving these questions, solving limits and continuity or differentiability or limits and derivatives? You should have basics of functions, domain and range. Okay, basics of functions, domain and range. Next, easiest topics. When it comes to limits, easiest topic is solving by direct substitution, factorization, rationalization, LH rule, all these things. These are the easiest topics. And continuity at a point. If they give continuity at a point or discontinuity at a point, they are all easiest topics. But when we talk about most repeated topics, we are getting 1 to the power of infinity form, infinity by infinity form, LH rule, okay, trigonometric limits. Okay, I told you about sandwich theorem. Next, continuity at a point, problems involving GIF. GIF means what? GIF means greatest integer function. Okay, I hope all of you know what is greatest integer function, or probably I'll take one more session where I'll be telling you about what is greatest integer function, what is modulus function, all these things. Next, okay, what are the key highlights? It is easy to moderate level. Continuity and differentiability require understanding of limits. This limits chapter is easy to moderate level, but why it is required to study limits in depth? Because it will help in continuity chapter, differentiability chapter, okay, which is the core of calculus. Okay, limits and derivatives is very important for understanding continuity and differentiability. Next, moving forward, let us start with our journey of limits. Okay, when we talk about limit at a point, I'm not going to tell you in depth what is limit, what is theoretical. I mean theory, we are not going to go in depth, but we'll tell what is required to solve the question. Okay, fine. So I told you for limits there should be LHL and RHL. Okay, so this is left-handed limit, this is right-handed limit. So what do you mean by left-handed limit? Okay, see here, limit f of x exists and finite where x tends to a minus, limit f of x exists and x tends to a plus, the value is finite, then also this LHL should be equal to RHL. Okay, what is LHL? Where x tends to a minus, RHL is where x tends to a plus, and that value should be existing, that limit should exist and that value should be finite. First it should exist, okay, and that value should be finite, and those two values LHL and RHL should be equal to each other. Then we say that limit f of x as x tends to a is equal to L. Well, L is some value of the limits, that is whatever the value we get for on computing this, that is L, right? That is the meaning of limit at a point. Now what do you mean by x tends to minus a, what do you mean by x tends to plus a? That is nothing but you must understand that x tends to minus a, okay, x tends to minus a doesn't mean that x is equal to minus a is not equal to x is equal to minus a. This you should know. And x tends to a plus, x tends to not is minus a, x tends to a minus is not equal to x is equal to minus a, x tends to a minus is not equal to x is equal to minus a, and x tends to a plus, okay, I am repeating again, x tends to a minus, I told you previously while talking about left-handed limit, x tends to a minus doesn't mean that x is equal to minus a, it means x is not equal to minus a, okay, and x tends to a plus doesn't mean that x is equal to plus a, x is not equal to plus a here. Okay, what you should understand is, suppose this is point A, okay, this x is approaching from left side, that is the meaning of a to the power of minus a, that is a minus. Okay, that is not a to the power of minus a, you should say it as x is approaching from left side, that is left side, that is how we call it as a minus, and x is approaching from right side, that is a plus, that is a plus, right side, that is the meaning of a plus, friends. Got it? So if it is approaching from left side, if it is approaching from right side, left side it is a minus, right side is a plus. Okay, one thing you must understand, they approach each other. From left side also they approach and right side also they approach, but they will never meet. Okay, they approach but they will never meet. So I can show it through a graph. See here, if x is approaching a, x is approaching a from left side. Okay, this is left side and this is from right side. D is from right side. If x is approaching a, here also x is approaching a, this function will come here and this will come here. This will meet at this point. Okay, they approach but they will never meet. Okay, that is the meaning of approaching. Got it, friends? They will approach but they will never meet each other. Okay, this is the graphical representation of a limit. Now going forward, these are the basics. Okay, now use LHL and RHL for what? What type of questions we have to use LHL and RHL? Okay, see, I discussed about LHL and RHL. For what type of questions we should use LHL and RHL? So suppose a question is a piecewise defined question, that is they give f of x is equal to x square if x is greater than 1 and is equal to f of x is equal to minus x square is x if x is less than 1. For such type of questions, what you should do? For such type of piecewise defined questions, a function has a split, there is a split. If it is x square, it is x is greater than 1, minus x square if x is less than 1. For example, for such type of questions, you can use LHL and RHL, and you can also use for greatest integer function. We can use LHL and RHL for greatest integer function and also for fraction and also for modulus function and also for square root. Got it, friends? So LHL and RHL you are going to use for piecewise defined functions, GIF, that is greatest integer function, fraction, modulus and also for square root. Next thing, so we have been given a question. Okay, we have been given a question, so we have to use LHL and RHL. Let us use LHL and RHL. I know this is a very simple question, but let us solve this. Okay, I'll give you 1 minute time. Please try to solve by yourself. Okay, tell me whether in the comment section, tell me what is the answer to this question, because this is a fairly simple question, very simple question. Got it, friends? So they have given x limit x tends to 2, modulus of x minus 2 divided by x minus 2 is equal to how much? Okay, so I'll write it as this f of x. I can write it as what? I can write it as equal to, this will be equal to x minus 2, this will be equal to x minus 2 if x minus 2 where x is greater than or equal to 2. Okay, it will be equal to minus x minus 2 where x is less than 2. Okay, here is the split. I have split it into two functions. Okay, this is a, per function is having a split, this is a piecewise defined function. So now if we solve, what will happen? If I take LHL is equal to limit, this will be what? LHL will be modulus of x minus 2 will become minus x minus 2 divided by x minus 2 as x tends to 2. So this will be equal to what? This will be equal to what, friends? X minus 2 by x minus 2, we will get it as, this will be minus 1. Now let us take RHL. RHL will be limit x tends to 2, we have to take this value, x minus 2 divided by x minus 2. So this will be equal to what, friend? This will be plus. So LHL is equal to 1 minus 1, RHL is equal to plus 1. So therefore LHL is not equal to RHL. This is a finite value, this is also a finite value, but they are not equal. That means what? Limit does not exist. That does not exist, that's it. Now we will talk about some indeterminate form. Okay, in this indeterminate form, this one is highly important and this one is also highly important, and this 1 to the power of infinity is also highly important, friends. 1 to the power of infinity is also highly important, and these two types we can solve using LH rule. These two types we can solve using LH rule, whereas this one there is one logarithmic or exponential limit. Okay, using that we can solve. That is called monkey on the tree. Okay, monkey on the tree problem, monkey on the tree property. I'll tell you while we solve this question. But these forms you can convert to this, you can apply this itself. You can convert to this form and solve this one. Got it, friends? These forms also you can convert to LH rule, convert to this form and apply LH rule and solve these questions. Right? Next one. When we talk about algebra of limits, okay, if limit f of x is equal to L, limit g of x extends to a is equal to m, then sum of the limits is equal to what? Sum of two limits is equal to sum or product of these two limits. Limit of sum or subtraction or difference of two limits is equal to sum or difference of their limits. That is, limit f of x or limit f of f plus or minus g extends to a is equal to limit f of x s extends to a plus or minus limit g of x or s extends to a. Okay, limit of sum of two functions is equal to limit of one function plus or minus limit of second function. Got a limit of first function plus or minus second function is equal to limit of first function plus or minus second function. Simple. Next thing, this is also, see here, limit of product of two functions is equal to limit of one function into limit of second function. Limit f of g of x is equal to limit f of x s extends to a limit g of x extends to a. Okay, product of two functions will give you this one. This is based on product property. Next one, limit f of x by g of x extends to a is equal to L by m. Okay, while solving this you will get L by m, where m should not be equal to 0. Then limit of product of a constant into some function will give you constant into product of the limit. Okay, constant into product of that limit. Okay, always constant will come outside, so that will be equal to what? That will be equal to constant, that is k itself. This is about algebra of limits. Now let us look at algebra of limits table. This is important. This I will say very important. Okay, based on this, why I am telling important? Because based on this, directly you can get answer to so many questions. Whether a limit exists, if it exists, what is the value, all these things. So here, let us interpret this table. So f of x, if f of x exists and g of x also exists, what will happen? If f of x and g of x also exist, then f of x plus or minus g of x, that will also exist, right? Then f of x dot g of x, that is the product, and also the division of the two limits of the two functions, limit of two functions, that will also exist. If both exist, this both will also exist. Next, if f of x exists but g of x does not exist, then what will happen to sum or difference? That will not exist. But when it comes to product and difference, that may exist. May exist means what? May exist means we have to check it whether it will, may exist means we have to check whether it will exist or not. Okay, we have to check it whether it will exist or not, we have to check it. May exist means, now f of x does not exist, g of x does not exist, then what about sum and difference? That is it will may exist, it may exist. Okay, it may or may not exist, but if it may, what we should do? We have to check. Okay, we cannot say directly, here we have to check. Wherever I have written may, there we have to check. Here also the product and what? Division, that may also exist. Okay, here also it is may exist. What we should do? We should do check this, whether it will exist or not, we have to check. But here, wherever it does not exist, it is definitely does not exist. That's it. Got it, friends? This is the interpretation of limit table, algebra of limits table. This will be useful when we solve questions. Okay, now we are going to see how we are going to solve the limits. Okay, there are various methods of solving the limits. One is called direct substitution. Methods of solving the limit. First one is direct substitution. Next is factorization. Next is rationalization. Okay, trigonometric limits, log and exponential limits, 1 to the power of infinity form, 1 to the power of infinity form. Next is infinity by infinity form. I told you when I told about indeterminate forms, I told about this also. Next is by expansion, then by LH rule. Okay, and in the trigonometric limits, we will also be using what? Sandwich theorem. Next one. So I told you various methods of solving the limits. Let us see one by one. So what do you mean by direct substitution? Okay, if by directly putting the value of f of that is x is equal to a, we get finite value, finite number f of x is equal to finite number L, or even if we get infinite number, fine. Okay, then directly we are getting the limits. We are directly putting x tends to something they give. That value if you put, if you are getting a finite value, or even if you get infinite value, that is the end of the limits. That is, we got the answer. So based on that, we will see one question. Although this is very simple, but still we will solve. Just you have to put the value. This will get us what, friends? Limit 3x square plus 4x plus 5. If I put the value, what we will get? We will get x square is 4 plus 5. We will get it as 7 plus 9. This will be 12. 7 plus 5. This will be 12. So this is answer is A. Directly we are substituting the value. Wherever x is there, we have to put 1. Got it, friends? Next one. Next one is based on factorization. When we will do factorization? Suppose limit is f of x by g of x is extends to, that is, this is of rational form. This is in the form of rational form or rational number, that is f of x by g of x. Then by direct substitution, if you put x is equal to a, if we get indeterminate form, the limit is in the rational form, that is f of x by g of x. Okay, if you put x is equal to a, then if we get indeterminate form like 0 by 0, infinity by infinity, or if we don't get a finite value, then we will go for factorization method. So factorization method, what we will do is, we will factorize both f of x and g of x. Based on the question, we will see, and we will factorize both f of x and g of x, either f of x or g of x. Sometimes we may have to factorize both. Okay, now then we will get something called, if x tends to a, we will get something called factor called x minus a. Okay, x minus a will be a factor, that x minus a will cancel it. X minus a will give a cancel it. What? Okay, x minus a we call it the culprit. Okay, why we call it the culprit? Because this x minus a when we get, we will cancel it. Okay, if we get x minus a, that is the one hiding the limit. If we get x minus a, we will be able to solve the question. By factorizing, we will get x minus a, that we will cancel it and we will be able to solve the question. Now what we should do after cancelling x minus a, what we will do? We will go for direct substitution. Right? Every time in the end, we will go for direct substitution, that we have to substitute the value. First we will factorize, then we will go for direct substitution. That is what I have written. Then we go back to direct substitution. Next one. This is about factorization. We learned two types of solving, that is direct substitution, and another one is factorization. Now based on factorization, let us look at this question. So they have given limit 3 power x by 2 minus 3 by 3 power x minus 9 as x tends to 2 is how much? So if I factorize this, what I can write here, this I'll take only this value. Okay, 3 power x by 2 minus 3. This I can write it as what? This is a square minus b square, because 9 is what? 3 square. So this I can write it as 3 power x square minus this will be 3 square. So a square minus b square is a plus b into a minus b. Since this is the initial class, I am writing the steps, but in the upcoming classes I will not write the steps. You have to understand. So this can be written as what? 3 power x by 2 minus 3 by 3 power x by 2 plus 3 into 3 power x by 2 minus 3. Okay, so we got it as x minus a, that is the culprit. So we will cancel it. So what you will get if you substitute the value of 2? You substitute the value of 2, you will get it as what? You substitute the value of 2, you will get it as 1 by 2 by 2 cancels, 1 by 3 plus 3, 1 by 6. That is 1 by 6 is the answer. Got it, friends? This is based on factorization. Now we will see rationalization. When we should go for rationalization? First I told factorization when f of x by g of x is given, that is in the rational form. Then we will factorize f of x and g of x, either f of x or g of x or both. And then we will go for direct substitution. We will get x minus a, that will cancel it. That I told is the culprit, right? So now when I talk about rationalization, f of x by g of x is given. One of them or both of them involve square root. This one. The square root if they involve. Whenever you see in a question, there is a square root or a root, okay, square root, then what you should do? You should go for rationalization. No second thoughts about it. When you see this square root, go for rationalization. We rationalize and then go back to direct substitution. Like I told you, final steps will be direct substitution. First we use rationalization. Rationalization when we see square root in the question. Now let us solve this question. See here friends, they are given limit x minus 3 by x square root of x minus 2 minus square root of 4 minus s as x tends to 3 is equal to what? Now if you rationalize, see here, this one will solve first, x minus 3. If you rationalize, what will get here? Square root of x minus 2 plus 4 minus x. This will be what? This will be square root of x minus 2 minus square root of 4 minus x into square root of x minus 2 plus square root of 4 minus x. We will get it as x minus 2 minus 4 minus x. We will get it. Directly I am writing. So this will become equal to what? This will become equal to x minus 3 into square root of x minus 2 plus 4 minus x will be equal to x minus 2 minus 4 plus x. So minus 4 plus x. So this will be plus x. So this will be what friends? This will be minus into minus is plus, minus 2 minus 4 minus x. So this will be a minus b into a plus b will be a square minus b square. This will be x minus 2 minus 4. Okay, this will be minus into minus is plus x. So this will be equal to 2x minus 6. I can write this as 2x minus 6. This will be 2x minus 6. Okay, or I can write this as, instead of this I can write this as 2 times x minus 3. 2 times x minus 3. X minus 3 cancel. So if you do direct substitution now, what you will get? X tends to 3, right? Okay, square root of 3 minus 2 is 1. This will be equal to 1. Square root of 3 minus 2 will be equal to 1. Square root of 4 minus 3, it will be equal to 1. So square root of 1 plus square root of 1 divided by 2. So square root of 1 plus 1 is 1 itself. This will be equal to 1 itself. 1 plus 1 will be 2. This will be 2. 2 cancel, you will get the value as 1. So here the correct answer is A, 1. Got it friends? This is how you rationalize. I have written this much steps for your understanding. Otherwise directly we can solve. In 2 steps we can solve. First step itself. Got it friends? These are we solve based on rationalization. Now we will see trigonometric limits. Okay, highly important. Okay, this I'll write it as very important. These trigonometric limits, they are highly important. Okay, so you must have learned the properties. You must have already learned the properties, but you should know how to apply this. But you must very much know how to apply this. Okay, so when it comes to competitive exams, what we see is students know the concept, but they don't know how to apply the concept into the question. So we will be helping you in bridging that gap. Now see here, they have given limit sin x by x as x tends to 0 is equal to 1, and also they have given equal to limit x by sin x as x tends to 0. So that means this limit will be equal to 1 and this limit will be equal to 1. But in actual sense, this value sin x by x will be actually less than 1. This value will be actually greater than 1. This will be less than 1. This will be less than 1. Okay, less than 1 means this one. This will be actually less than 1. This will be greater than 1. This value will be greater than 1. Less than 1. Suppose if they give limit x tends to 0 sin x by sin x. Okay, students will get confused here. Since they are given limit x tends to 0 sin x by sin x, they will write answer as 1. But this is what friend? This is greatest integer function. This is greatest integer function. So greatest integer function, what it will do? Sin x by x, this is less than 1. This will take it to a point where it is 0.00 something. Okay, so this will be actually equal to 0. Okay, this is important, you should know this. Okay, because this is greatest integer function, this is not just sin x by sin x to write it as 1, this is greatest integer function. Got it? Next, limit tan x by x is equal to 1, limit x by tan x is equal to 1, and s extends to 0, extends to 0. Here this actually, this value is, this is less than 1, no, this value will be actually greater than 1, here it will be actually less than 1. Okay, now limit sin inverse of x by x is equal to 1, limit x by sin inverse of x is equal to 1, similar to previous one. Got it? Limit tan inverse of x is equal to 1, limit x by tan inverse of x is equal to 1. I need not explain, cos x is equal to 1, limit cos x as extends to 0 is equal to 1. Okay, because what we know, cos 0 is equal to 1, we know that. Limit sin inverse of x as extends to a is equal to sin inverse of a, where modulus of a is less than or equal to 1, limit cos inverse of x is equal to cos inverse of a. These are all fairly direct. Okay, tan inverse of x is equal to tan inverse of a. Now have a look at this. Limit sin x by x is equal to limit cos x by x is equal to 0. Okay, now I want to point out this, very much important, because why no, limit sin x by x actually is equal to 1, limit what, tan x by x is equal to 1, limit sin x by x, and they are telling limit cos x by x is equal, but there we didn't say it is equal to what, 1. I mean for cos x by x we didn't say. Here we are saying limit sin x by x is equal to 0, we are saying. Why? There, here the limit is tending to 0. Here the limit is tending to what? Here the limit is tending to infinity. Here the limit is tending to infinity. Limit sin x by x as extends to 0. Limit sin x by x as extends to 0, the value is equal to 1. Limit sin x by x as extends to infinity, the value is equal to 0. Limit cos x by x as extends to infinity, that is also equal to 0. If it extends to 0, it is 1. If extends to infinity, it is 0. Got it? What? Limit sin x by x. And when it is greatest integer function, then also it is 0. Now this is sandwich theorem for all x, where f of x is greater than or equal to g of x, okay, but less than h of x. If limit g of x as extends to c is equal to limit h of x as extends to c is equal to L, then limit that f of x as extends to c, that will also be equal to L. So this is about sandwich theorem, that is f of x is greater than g of x but less than h of x. If limit of this is equal to L, if this is limit of this is equal to L, then limit of this one will also be equal to L. Okay, this is what sandwich theorem says. Let us see through an illustration. Suppose they are given limit x square sin of 1 by x as extends to 0. Okay, we know that sin of 1 by x, the range of sin of 1 by x is what? Sin of x is what? -1 to +1, right? This is, let me take another color. This will be equal to what? This will be, the range of this is -1 comma +1. So if I write sin x, this will be greater than or equal to -1, less than or equal to 1. Now both the sides if I multiply by x square, this will be -x square, this will be x square, this will be x square sin of x. Okay, so here I told you, as per sandwich theorem, this will be f of x greater than or equal to g of x, and this will be less than or equal to h of x. That is what we have written. G of x is -x square, f of x is x square sin of 1 by x, h of x is x square. Now if you take limits, limit g of x as extends to 0, limit g of x as extends to 0, limit -x square as extends to 0 is 0, because by direct substitution this will become 0. H of x also by direct substitution it becomes 0. So if these two are 0, then definitely this value will also be 0 by what? By sandwich theorem. Got it, friends? By sandwich theorem, this will also be equal to 0, right? So for trigonometric limits, for some of the questions we will be using sandwich theorem. Got it, friends? For trigonometric limits, for some of the questions we will be using sandwich theorem. Now let us look at some of the questions based on trigonometric limits. Okay, see here they are given limit 1 minus cos 2x sin phi x by x square sin 3x is equal to this one. We will not use traditional method where we will take some use various steps to solve this question. No, we are not going to do that. I take only this value. See, 1 minus cos 2x into sin 5x by x square sin 3x is equal to, we have to find out 1 minus cos 2x. We know that it is what? 2 sin square x. 2 sin square x. Here it is 2x. I'll write 2x. Okay, so 2 sin square 2x. 1 minus cos 2x is not sin 2x, not sin 2x, sin square 2x. It is sin square x. Sin 5x, I'll write it sin 5x. Sin 5x, I'll write it sin 5x by, I'll write here x square sin 3x by x square sin 3x. This is what we have. But we have know the property of limits. Limit x tends to 0. Sin x by x is what? Sin x by x is equal to 1. So here we have what? Sin square x. But so we should have here x square. Here I have written x square, so I will multiply by x square. Here I have what? 5x. So I will write 5x here. So I'll multiply by 5x here. I'll multiply by 5x here. Here I have what? Here I have what? Sin 3x. So I'll write 3x here. So I'll multiply by 3x. Okay. Now what will happen? This will be equal to what? This will be equal to 1 sin 5x by 5x. Limit as x tends to 0. I am not writing limit, directly I am writing this will be equal to 1 and this value will be equal to 1. Right? This value will be equal to 1. Now we have what? Now we have here x cube is there. Right? Here x into x is x cube. Here x square is there. Here x square is there. Here x is there. Here x is there. I'll cancel. Now what I am left with? I am left with 2 into 5 by 3. That is 10 by 3. Got it? What is the answer? The answer is here 10 by 3. Directly we can solve like this. Okay, directly we can solve like this. No need to further simplify and all. Otherwise, by looking at it only, directly we could have written this step. No need to copy this also. Directly you can write it down and we will get 2 into 5 by 3, that is 10 by 3. Directly we will do. We didn't even take 1 minute to solve this question. Understood, friends? This is how you should be fast while solving questions of MSET, KSET and JEE. So let us look at another question. Okay, we will solve JEE question. 1 minus cos 2x into 3 plus cos x by x tan 4x is equal to how much as x tends to 0. Okay, so what we know directly, what is actually obvious, we should take it obvious only, right? So we note this will become 3 plus cos x. So cos 0 is what? If I apply it, this is limit f of x into g of x, that is product of limits. So 3 plus cos x, that is 3 plus cos 0. Cos 0 the value is 1. So this will become what? This value will become 1. So 3 plus 1, this will become 4. So I can write it as this will become 4 times limit 1 minus cos 2x by x tan 4x. Okay, this is the limit we have as x tends to 0. Now I'll take only this. So 4 into, I'm not going to write the limits because directly we know that what is the limit. 1 minus cos 2x is what? 2 sin square x. 2 sin square x. 1 minus cos 2x is 2 sin square x. Okay, by, I'll write x tan 4x. Okay, we know that sin x by x, limit sin x by x is equal to 1, but here we have sin square x. So I'll write here x square, I'll multiply by x square. Here what we have? Limit tan x by x is equal to what? 1. But here we have tan 4x. So I'll write divide by 4x, multiply by 4x. Divide by 4x and multiply by 4x. What will this value be? This value will be equal to 1. Okay, this value will be equal to 1. You must be wondering, sir, the limit is sin x by x is equal to 1. Why you are writing sin square x by x square is equal to 1? So sin x by x into sin x by x, that is nothing but sin square x by x square. That's it. 1 into 1 is 1 itself. Directly I am writing this value is equal to 1. Similarly, this value will also be equal to 1. Now what I am left with? I am left with here x into x is x square. This x cancels. X square cancels. So I am left with what? I am left with this 4 and this 4 I am left with. then I'll have the value of 2. So here friends, the correct answer is 2. Here friends, the correct answer is 2. So we'll continue in the next session. Okay, in the next session for remaining types of limits. So we learnt about what is a limit, okay, trigonometric limits. What do you mean by how to solve the limits? When we solve direct substitution, when we should use factorization, when we should use rationalization, then we learnt about trigonometric limits. Right friends, in the next class we will learn some more concepts and then we will do the PYQs of MSET, KSET. Got it friends? Thank you so much. Take care.